In this section, I'm going to finish off, well, let's see, hopefully, the exponential graph, okay? Now, the exponential graph, if we remember from the past, it is going to be equal to, it's got its own specific one, exponential, the exponential graph, and we had a standard form, y equals a b to the x plus q. Remember, and q is the up if it's positive, down if it's negative, and essentially q, okay, q is equal to, it's our y, isn't it? And it's going to be equal to the horizontal asymptote. It's going to be the horizontal asymptote at the end of the day. Now, we are going to introduce p. No prizes for guessing that we're going to do that, right? What are we doing? We're going to say, okay, how? So we say new standard form. The new standard form, okay? It's going to be equal to y equals a times b to the x minus p plus q. And in this case, p is not a left, right. Okay? P is not a left or right. It has to do with the shape. P affects the shape. Okay? Now, all right, here's an example. Let's just do an example straight off. An example straight off, we say, all right, sketch the graph of y equals minus a half 2 to the power of minus x minus 1, okay, and plus 1 over there just for good measure. Okay, step 1, okay, we're now looking for the standard form. So we've got that, so I write down here a b to the x minus p, okay, plus q. Well, straight away I can you see here, we've got to do a bit of rearranging because that's minus x and here's an x. So I can't leave it like that. I have to do a little bit of manipulation. My manipulation is going to be y is equal to minus a half. And can you see over here, let me just get rid of that little smudge. I want an x, so I'm going to say it's 2, there we go, to the minus 1, and that gives me x plus 1. Can you see that? I took a minus 1 out because I want an x in front. That gives me x plus 1, doesn't it? Right? And plus 1 still. So now I bring that minus 1 into the bracket, and it becomes a half, right? To the x, but hang on, x plus 1 is x minus minus 1, so my p is minus 1. Can you see? Right? I hope so. Let's recap it. I need to get it into an x minus p format. Currently it's a minus x. So you take out a minus 1. There it is. There. And that minus 1 is now going to go into the brackets. And that becomes 2 to the minus 1. 2 to the minus 1 is 1 over 2. Okay? Leaving us with the x plus 1. Okay, I want it in that format there, x minus p, because I want to know what p is. Therefore, it's x minus minus 1. And now we can write down the parameters. We can say a is going to be equal to minus a half. B is going to be equal to a half. P is going to be equal to minus 1. Q is going to be equal to plus 1. So we've identified and isolated all of our parameters now. The next step that we're going to go for is we're going to say, as usual, step 2, let x equal 0. Because what you're going to do is you're going to say, okay, a is less than 0, therefore it's under the asymptote, etc. I'm just going to do it slightly different, all right? We are going to go through those steps, but I'm just going to find the graph and then we can talk about the steps, all right? Remember, if you cannot remember the steps, right, which we get to later, if you can't remember them, carry on, right? Don't just say, I can't remember the shape, but you can carry on. I'm going to show you that you don't need to do all of that if you forget it. The shape will come by itself. Let x equals 0. Therefore, I say y is going to be minus a half, okay, to the power of, or rather a half to the power of 0 plus 1, which is going to be minus a half, okay, to the power of times a half plus 1, okay, which is minus a quarter plus 1, which is going to be equal to 3 over 4. Therefore, 0 and 3 over 4. That's my first point on the graph that I've got. The next point on the graph that I'm going to find is I'm going to say let y equal 0, aren't I? Okay. And the other thing is if you do those formulas up front for the shape, let me not talk about it, we'll do that at the end. Let y equal 0, so I say 0 is going to be minus a half to the x plus 1 plus 1. Step 1, always take this to the other side. All right. So we are going to then say that minus 1 is equal to minus a half to the half x plus 1. What do I then remove the coefficient here. Get that to the other side. Okay. So then I'm going to multiply by minus 2. That gives me 2 equals. Okay. 2 equals a half to the power of x plus 1. What is it? Exponential. I want the bases the same. Therefore, I can change that or that. So I'll say 2 equals 2 to the minus 1 times x plus 1. Therefore, 2 to the 1 is equal to 2 to the minus x minus 1. Drop the base. 1 is equal to minus x minus 1. And you get x equals, let me just check what my x equals. X equals minus 2. And I then say minus 2 and a 0. All right. So now we've got two points, and the last one we say, let me just check what number. Number 4. Okay. Number 4 was the asymptote. Is q. Q, which is equal to, in this case, 1 plus 1. Remember? Let's now go and see, let's put our points in, shall we? All right. Let's just put a few points in over here. Right. Put it over there. And I say, right, I can plot point y equals 1. Let me just change color. Green. Let's say I couldn't work out what the shape was. Why? That is given. That's from my graph. I have just calculated the following points. X equals minus 2, minus 1, minus 2, and 0. I've just calculated that. The next one I calculated was, let me just go there. I said that x equals 0. If x is 0, it's 3/4. So I can plot that point. If x is 0, y is going to be 0 and 3/4, right? Now I have got no clue what this looks like, okay? Because let's say I couldn't work out. For example, up here with all of these things, let's say over there I turned green, okay, and I got confused. All right? Because you have to do the test for is it above or below the line? Is it an increasing or a decreasing function? Using A's and B's and Q's, right? If you forget that, carry on, right? Just carry on. Plot the points, plot the graph, and in any event on an exponential, what do, right? The next step is what number? Number 6, because 5 is plot the graph. 6 is plot, plot one other point and show it. Okay, so usually x equals 1, x equals 2, x equals minus 1, x equals... Why? Because they are the simple ones. Let's not choose a difficult one. Choose an easy one. All right? Now, therefore, if I plot x equals 1, x equals 1. Therefore, y is going to be equal to a half times a half to the power of 1 plus 1 minus 1. I work this out and I get 7 over 8. So my point is 1 and 7 over 8. Okay. Now I go back to my graph and I go and I say, okie dokie, at 1, it's 7 over, so it's higher. So my graph has to do this. Okay, like that. From plotting this point 1 and 7 over 8, because 7 over 8 is higher up on the y-axis than that. You could have plotted minus 1 and get a point there. Well, in this case, you can't plot 2 or 2. You could have plotted, and you see it's getting closer to that. So if you get confused with all of the tests, right, just ignore and go through, find x equals to 0, y equals to 0, and your asymptote, and draw it. Okay? Then you've got your graph at least drawn. Okay? Right. Now we say, okay, let's apply the filter to the problem, all right? Right. We say, first of all, if we are going to use the top, let me go back to this graph over here and do it up there with the, where I said confused. Can you see I'm going to now use, these filters. Because that's what they are, isn't it? It's just a filter. I'm going to actually use them now. I'm going to say, right, in this case, step 1, okay, all right, we say, right, is it in this case going to be above or below, right? A is less than 0, therefore below, right? And, okay, in this case, yes, B is less than 1, okay? So it's below the asymptote, okay? And then we say, right, 0, okay, so now we know position. Let's say this gives us position, which was above or below, that's terrible, above or below the asymptote. All right, so we've now got our situation. We can say, okay, we know it's below the asymptote based upon the set of filters. The next we say 0, we're now going to test for increasing or decreasing functions. What do? Okay, I say, right, have a look. A is less than 1 and B is between 0 and 1. Okay, can you see that? Because B is a half. B equals a half. A equals minus a half, right? You can see those on your work schedule. So we say A is a half, minus a half, so it's less than naught, below. B is a half, therefore it lies between there and there. Okay? Then, therefore, that means the graph is increasing. Therefore, if we had our asymptote, we had the graphs are below, so it's either there or it's there. Oops. Let me just do that a little neater. That was a bit squiffy. Not cool. Okay. Let's just take a bit more time. We said, right. Now we know the asymptote in this graph is at, 1. Okay, y equals 1 is an asymptote. So now that we know that the graph, remember we're looking at the shape. The graph is either going to go that way or that way somehow, right? This would be increasing, this would be decreasing. If it's an increasing graph, it means it's under the asymptote that way, which agrees with our shape plotted. Okay? Not too difficult to do. Let's do another one. Okay? Let's do another one of these, shall we? Okay, we've done U. Okay, wait. Here's another one, I think. Sketch this graph. All right. Example. Sketch. Okay. Y equals minus 2. 2 to the power of x plus 2 minus 2. Okay, is it in standard form? Y equals a to the b, x minus p plus q. Yep, I don't have to manipulate. It's all cool. Therefore, I can say, therefore, a is equal to minus 2, b is equal to 2, and p is equal to minus 2. That's a 2 there, by the way. Okay. And q is equal to minus 2. Did you see where I got that from over here, by the way? That's a plus 2. So it's x minus minus 2. That gave me my p over there as a minus 2. Okay. Therefore, now shape, let's just use the filters. This is using the filters. Shape. Okay, just, come on. I want to erase you. Okay, shape. A is less than naught, therefore below the asymptote. Okay, and B is greater than 1, therefore decreasing. So it's going to have an asymptote there and a function dipping down like that, isn't it? What's my next step? Well, my next step is going to be let x equal naught, correct? Right. Let x equal naught. If I do that, I get y equals minus 2 to the 2 to the power of 0 plus 2 minus 2, which is going to be equal to minus 2 times 4 minus 2, which is minus 8 minus 2 minus 10. Put my coordinate down, 0 and minus 10. Remember, if I'd got confused in the beginning, just keep going. Don't stop. Ignore that bit with an exponential and come back later, because there's a lot of confusing pieces there, right? You can always come back to it later to figure it out, but get the graph drawn, because on the graph drawing, plotting it and putting in everything all counts for marks. So just because you forget that, just ignore that. Yes, there are some marks there, but that's not what it's about. It's about finishing this thing. So we say, okay, my next is let y equal naught. So I say 0 is equal to minus 2, 2 to the power of x plus 2 minus 2. What do? I take that over. I say 2 is minus 2. 2 to the power of x plus 2. Then I take that over and I say that's minus 1 is equal to 2 to the power of x plus 2. No solution. Why not? You cry out in anger and amazement. Why? Because I can't put anything to a power and get a negative number. Students would be tempted to write that minus 1 equal to minus 2 to the power of 0. Okay? Okay? So what are you going to get? You're then going to drop the base, right? But you're going to put that equal to 2 to the x plus 2. All right? And what happens here is you can never get something to the power of something to be a negative number. All right? It ain't going to work. Okay. So, what do we say here? Well, can you see the erroneous thing there? What has happened is it's just been dropped away. Then students, I'm not going to do it because people then might say, okay, that's away. There's no solution to that, okay? It means that what happens, okay? Therefore, we can say, all right, leave it in red. It does not cut the x-axis. Y cannot be equal to 0. Then we go to our graph. We say, cool, let's have a look. Okay, how do you look? Well, I'm going to do you. What did we say? Y equals minus 2. Y equals minus 2 was over there, wasn't it? Minus 2. And we said plot a point 0, 0 and minus 10 over there. And we said the graph was a decreasing function. So it did this. And lastly, remember, lastly but not leastly, plot another point and label it. Okay, this is where you'd go if you didn't know how to work out which way it goes. Okay, in other words, if all those filters at the beginning got you confused, you've carried on and you've found that point and you've found that asymptote. That's what we know. We plot one more point, put x equal to 1, and you get y equal to minus 18. So therefore, you've got a point 1, and, come on, minus 18. And I go and plot that. Let me see where it is. Blue, I go 1, there, 1, and minus 18. Now, if I didn't know which way it went, okay, what do I know? I know that it either goes, the asymptote was there, so it's either going that way or that way, isn't it? Okay? It's either increasing or decreasing. Hello, you know that point and you know this point. Right? So it has to be that one, doesn't it? You can't draw one going the opposite way. Okay? That is the simplest way to go about these characters. Okay? Okay. The last part of this, okay? The last part of this, and we're almost there, is where they say to you once again, they say, find the equation given. Okay? So this is our find the equation given. It goes through some points, okay? How do we do it? Write down standard form. Oh, we know that. Standard form, okay? Y equals A, B, X minus P plus Q. 2. Put anything given into the equation. All right. In the case I'm doing over here now, all right, in the one I'm doing over here, they have said to us, okay, find f of x equals a half 4 to the power of x minus p plus q, right? They tell us that there is a horizontal asymptote at 3. Okay, horizontal, that means, therefore, y equals 3, y is q, therefore, f of x must be equal to a half 4 x minus p plus 3. Correct? So far, so good. The last thing they tell us, okay, is that it goes through the point 3 and 5. Okay, at that, and I should have written it there, and it passes through a 3 and 5. There we go again. Can you see? Oh, f of x is equal to a half 4. Oh, but f of x, they've told you. F of x is y. Y is 5, is equal to 3 minus p plus 3. Okay, these are all going to be the same. Okay, this is what they're going to give us, and this is what we have to do with them. Basically, you're going to put in the asymptote because they'll give it to you, and you're going to find the p from that point. Okay, so I've got that. Therefore, I take the 3 over and I get 8. Remember, that's going this way, is equal to a half 3 minus p. The next step is times by 2. 16 is going to be equal to 4 to the power of 3 minus p. Let's be purists, okay? What is that? It's an exponential equation, isn't it? Why? Because the p is on top, so it's an exponential. The next step would be prime factors. Remember what we did in all of this? That is 2 to the power of 4 is equal to 2 squared 3 minus p. All right, I know I could have just put that 4 squared. I'm being a purist, showing you if it wasn't as straightforward. Therefore, we can say 2 to the power of 4. Remember, the next step in the recipe was remove the brackets. 2 to the power of 6 minus 2p. Now I can drop the base. 4 is equal to 6 minus 2p. And you end up with 4 minus 6 equals minus 2p. And I think the last bit here is minus 2 equals minus 2p. P equals 1. Therefore, the equation is y is equal to 1/2 4 to the power of x minus 1 plus 3. Done and dusted. Okay? Okay. Guys, I hope that exponentials are there. We've gone through this quite slowly, and I've done, as I say, loads of examples. Go through them. Work them through. Get the answers with me. The point is, the ones I'm doing are the ones just about as difficult as you're going to get. There's none that are going to give you more hassles than these will. So give them a go, and remember, once again, this is the basis, huge basis of everything else we're going to do. It's worth putting a lot of great and good and solid attention in this so that we get the foundations right for the rest of where we're going. Cheers. Thanks for watching. Have a great one. Bye.